Okay, as I said, today we start our discussion on stock valuation. That topic of bond valuation is over. The dark 2 weeks are finally over, and you have bright 2 weeks coming up. Today and Wednesday and Monday, and next Monday, we'll talk about stock valuation, and that will be followed by capital investment decisions for a couple days. Then you will have your midterm exam, which will be coming up on the 6th of May. That's Wednesday, 2 weeks from this Wednesday. There will be a review session on Monday, one day before 어린이날. And midterm exam will be covering bond valuation, stock valuation, and the first topic of capital investment decisions. Okay, any questions or comments? So we will go into common stock valuation. There are three main topics of common stock common stock. The first one is common stock valuation. We'll spend most of our time on common stock valuation. Some features of common and preferred stocks will be very briefly covered. The stock markets are also briefly covered on Monday. So we'll go into common stock valuation. Common stock is essentially common stock denotes ownership of the company. Common stock is essentially ownership of a company. If you own common stock of a company, then you are an owner. You are not a 100% owner. I wish you were, but you are not. You are a partial owner. Even if you have one share of Samsung Electronics, you are an owner, partial owner of Samsung Electronics. So you are entitled to all the benefits that will accrue to a stockholder, even if you have only one share. Now suppose if you buy a share of stock, in other words, you buy one share of a stock, then you become an owner, partial owner of that stock, of the company, then you can receive cash flows in two different forms. The first form is dividend. You receive dividend, the company pays, and you are going to receive cash for the sale of your common stock. If you happen to sell the common shares, you will receive the price for the common shares. You sell your shares either to another investor or another investor in the market or back to the company, you will receive cash in that way too. As with bonds, the price of the stock is the present value of these expected cash flows. So if you draw a timeline, you can see very clearly at time 0 and at some future time, let's call that 1 year later, and you are going to receive dividend per share for each share, and let's call that dividend per share at time 1, or more simply D1. Okay, and price at time 1, or P sub 1. These are the cash that you will receive from the ownership of the company. So buy one share, paying P0. That's today's price. You pay today's price to receive future cash flows in dividend and in the price. Here's an example. Suppose you are thinking of purchasing the stock of Moore Oil Incorporated. You expected to pay $2 dividend in 1 year, So dividend per share is $2. And you believe that you can sell the stock for $14 at that time. So price at time 1 is 14. If you require a return of 20% on investments of this risk, so this is a very important phrase, 20% on investments of this risk. You require a return of 20% on investments of this risk. And that required rate of return, and this is denoted by R, big letter, capital letter R. This depends upon the riskiness of your investment. Okay? This is for a given level of risk, there is required rate of return on investment, R, and let's assume that that required rate of return is 20%. Then you see the setting is very similar to the present value computation setting. Future cash flows and discount rate, and it is automatic for you to be able to compute present value of it. And when required rate of return is used to discount future cash flows, that will become the price. So price of this stock is equal to future dividend, DPS 1, plus price 1, discounted by 1 plus R. So $2 dividend plus $14 price, discounted by 1.2, and that gives you the value of $13.33. This is the price of the stock. We use this phrase that the company Moore Oil Incorporated common stock is priced to yield 20% return for the cash flows consisting of dividend per share of $2 and price per share of $14. Okay? The stock is priced to give a return of 20%. The price is determined to give you the return of 20% for these cash flows. So these cash flows are 20% higher than the price you pay. This is the pricing relationship of a common stock. This is simple definition of common stock valuation. It's easy. It's a lot easier than bond valuation. Bond valuation, we have to know all these things. This is simple. Price is future dividend plus future price discounted one period by 1 plus R. Just like bond valuation, bond price is discounted value of future cash flows using appropriate discount rate, so-called yield to maturity. Is it okay? Is it clear? Now let's move. This is the same thing using this graph or this picture. Okay, dividend at time 1 is $2 per share, and price at time 1 is $14 per share, and $16 is the future cash flows, and discounted by 20% required rate of return to yield $13.33. That's the price of the stock. So the same is shown on that graph. Now, instead of going through that, let me use my own way of explaining this. So price is equal to D1 plus P1 divided by 1 plus R. 1 plus R is given for a given riskiness. For this riskiness, it was 20%. So it's given. D1, it's not very hard to find. Dividends, if you check the dividend per share of the company you chose, look at that, and there is very stable growth. The growth path is very stable, and it's quite smooth. So dividend is not terribly hard to forecast. Dividend, especially next period dividend. But price for next period, P1, how do you know? The example says you can sell the stock for 14. You believe that you can sell the stock for $14, but that's your belief. But will it be really $14? You're not certain. Here's a student in mathematics comes over and says, simple, Mr. Choi. This is simple. P1, you know what P1 is? P1 is, using the definition over here, is D2 plus P2 divided by 1 plus R. So put it over there. You have D1 plus D2 plus P2 divided by 1 plus R over 1 plus R. Does this solve the problem? No, it doesn't, because you don't know P1. But if you don't know P1, it will be even harder to know P2. And this mathematics student comes back and says, look, it's easy. P2 is D3 plus P3 over 1 plus R. This is ridiculous. But if you go on and on and on, eventually P0, I don't think you can see it. Eventually, it will become like P0 is equal to sum t starting from 1 to infinity, because common stock, there is no finite life. dt divided by 1 plus r TS power. Price of a common stock is discounted value, the sum of the discounted value of future dividends. All the future dividends are discounted using the discount rate R, and you add them up. All the future dividends are discounted to present value, and you add the dividends, and you will have the price. So common stock price is nothing but discounted value of future dividends. This looks easy and simple. But this one gives you a difficulty, because you will have to forecast future dividends. Not only 1 year from today, but 2 years, 3 years, 10 years, 20 years, 50 years, and 100 years from today. All of a sudden, this seemingly operational formula becomes unoperational. Mathematics made it look simpler than before, but it is impossible to operate. In order to make this thing operational, you have to make a few assumptions. And today we are going to talk about these assumptions and the resulting formulas for common stock values. And this is the continuation of the discussion that I showed on the board. Two-period example. Now, what if you decide to hold the stock for 2 years? In addition to the dividend in 1 year, you expect a dividend of $2.10, $2.10 in 2 years, and a stock price of $14.70 at the end of year 2. How much would you be willing to pay? And the same two-period example, the timeline is used to discount to compute the value. D1 is discounted once to yield $1.67, and D2 plus P2, that's $16.80, discounted for 2 periods to yield $11.67, and if you add the 2, it will be $13.33. Now, 3-period example. Go to 3-period, and you do the same routine, and you get the same answer. The problem is designed to give you the same price per share. So this is what we have. So in order to make this operational, you make one of the 3 assumptions. The first assumption you make is constant dividend. Dividend, from now on, from here to eternity, that's a famous movie title, From Here to Eternity. From now on until infinite time horizon, the firm will pay a constant dividend forever. Constant dividend forever. This is like preferred stock. Preferred stock pays constant dividend forever. Preferred stock of the United States. Korean preferred stock is a little different, a different kind. But US preferred stock pays constant dividend forever. The price is computed using the perpetuity formula. It's a perpetual cash flow, so you use perpetuity formula. And we'll get into the example soon. Constant dividend growth. The firm will increase the dividend by a constant % every period. Every period, dividend is growing at a constant percentage. The growth rate is constant rather than dividend amount is constant. Dividend is growing at 5%, 10%. Growth rate is constant, so growth will occur exponentially. The price is computed using the growing perpetuity model. Forget that. I will explain to you how to do it. Now, supernormal growth is dividend growth is not consistent initially, but settles down to constant growth eventually. The price is computed using a multi-stage dividend model. Famous companies like Apple Computer or Google or some high-tech companies, initially they pay no dividends. No dividends. High growth companies pays, in general, no dividend or little dividend. And as soon as they pay dividends, dividend growth occurs at very phenomenally large rate, like 80% growth or 100% growth, very high growth for the first few years. And later on, that tapers down, tapers off, and it will become a 5% growth or 10% growth. So there is growth stage, supernormal growth, and then followed by normal growth. So multi-stage model is useful for that. And we'll get to some examples. Now, the first example is zero growth. If dividends are expected at regular intervals forever, then this is a perpetuity, and a present value of expected future dividends can be found using the perpetuity formula. Price at time 0 is next period dividend, D0 or D1. It's the same, divided by discount rate R, required rate of return R. Very simple formula. So look at one example. Suppose stock is expected to pay 50 cents dividend every quarter, and the required return is 10% with quarterly compounding. So that's 10% is annual rate, and given quarterly compounding, quarterly discount rate is 2.5%. 10% divided by 4. Each quarter, it's 2.5%. What is the price? Price is nothing but 50 cents dividend discounted by 2.5% discount rate, and that yields $20 price. So the price of the preferred stock is 20. So if it's a simple the preferred stock, the formula is very simple, and your life is very easy. But life is not that easy. Common stock valuation is there is a little more to common stock valuation than this. Let's get to this. Dividends are expected to grow at a constant % per period. with a little bit of algebra and some serious work, this reduces to. Let me use this example. If future dividends, if dividends at time t is dividend at time t minus 1 times 1 plus growth rate g, this is a general assumption. Dividend grows at constant rate g, then this whole formula becomes a simple fraction, d1 divided by r minus g. This formula, I'm afraid to ask you to memorize it. And this is hard to memorize. Okay? D1, which is expected dividends. D1, not D0. D1, expected dividends divided by R minus G. R is discount rate or required rate of return minus growth rate. And let's do a few examples. Constant dividend growth model, example 1. Suppose Big D Inc. just paid a dividend of 50 cents per share. That's Z sub 0, D0, okay? D0 is 50 cents. It is expected to increase its dividend by 2% per year, so growth rate is 2%. If the market requires a return of 15% on assets of this risk, required rate of return R, big R is 15% for this risk. How much should the stock be selling for? What's the price of the stock? And using the straightforward application of this growth formula, this dividend valuation formula, price is D1, which is D0 times growth rate, 1 plus G, divided by R of 15% minus growth rate 2%. That gives the price to be equal to $3.92. It's simple, right? You can do it. So I will ask one of you to come out and do the next example. Suppose TB Pirates is expected to pay $2 dividend in 1 year. If the dividend is expected to grow at 5% per year and the required return is 20%, what is the price? Okay, who wants to come out and solve this problem for all of us? Volunteer. Unless you volunteer, I will ask you to come and do it. Is there anyone who wants to be a Black Knight? 흑기사? Anyone wants to come and? Okay. Let's see. Let me ask Won-Seon. Where are you, Won-Seon? Can you come out and solve this problem? It's in your notes. Anyone wants to help Won-Seon? Won-Seon's Black Knight, 흑기사? Anyone? Okay. 오준혁. Where are you? 오준혁. Will you come and solve? You can speak in Korean. You don't want to do it? Huh? Next time you do it, okay? Next time. 이주현. Will you? Please. You don't have to speak in English. You can speak in Korean. Okay. if Lee doesn't want to do it. Lee doesn't want to do it. Let me go to, let me see here, Choi Yubin. Let me ask Ko Hong-gun. Ko Hong-gun, come out and solve it. Please, you can do it. Okay.
Dividend is $2. R is 20%.
Growth rate is 5%.
Growth rate is 5%.
You don't have a calculator, okay? I will write instead of Ko Hong-gun 13, 33. Right. This is all I wanted you to do. So that's good. Give him big hands. Okay. Why isn't the $2 in the numerator multiplied by 1.05 in this example? Well, the reason is $2 is already expected dividends. Dividend is expected to pay $2 dividend. Okay, so D1 is already D1, not D0. D1 is given as $2. By looking at this formula, or by looking at this graph, you can see that price of the stock is positively related to the dividend growth rate. If growth is 0, what is the price? If growth is equal to 0, recall dividend is 2 and R equals 20%. And if dividend is equal to 0, dividend growth is equal to 0, the price is 22 divided by 0.2, so it's 10, right? Price is $10 if dividend growth rate is 0. If dividend growth rate is 20%, what happens? Price is 2.20 minus 0.20 and explodes, right? So it's not possible. Implicit assumption of this model is R is always greater than G. If G is greater than R, then the denominator becomes negative. Therefore, the whole number becomes negative. And that doesn't make any sense. So the implicit assumption of this model is R is greater than G. Okay? Can you follow me? So there is this relation that the higher the growth, as growth becomes larger, price becomes larger too. So price of the common stock is positively related to dividend, to growth. How about R? If R grows, if R becomes larger, price becomes lower, obviously. Okay? So the higher the required rate of return, the lower the price. If market expects more from the stock, then the price will have to fall to give more return on investment. How is R interpreted, or how is R determined? What determines R, market's required rate of return? The chief determinant of R, required rate of return, is riskiness. So risk of the stock goes up. What happens to R? The higher the risk, the more the market wants to require from owning that asset. Therefore, risk goes up, price falls. So here are some fundamental relations. Growth, the higher the price. The higher the risk, the lower the price. Are you with me? Okay. And this model is called, it's named after the inventor of the model, or developer of the model, Myron Gordon's growth model. And here's an example. Gordon Growth Company. Gordon Growth Model is applied for Gordon Growth Company. Gordon Growth Company is expected to pay a dividend of $4 next period, and dividends are expected to grow at 6% per year. The required return is 16%. What is the current price? And this time, I've asked people on this side, and I'm going to ask people on this side, any volunteer to come out and solve this problem for us. It's already in your notes, so you just come out and explain it. You don't even have to speak in English for that. I'll give you that much of... anyone wants to volunteer for this? You know, your class participation grade is determined by class participation of this kind. Sujin, would you try? Bring your note out with you.
D1 is $4 and growth rate is 6%.
Will you write it over here?
6% and rate of return is 40.
Okay. Let's see whether Sujin did it right by looking at, 40. So let's give her big hands. Between now and the end of the semester, all of you, with no exception, will be asked to come out and do the problem like this. Okay? So be prepared. Be prepared. Okay. Remember that we already have the dividend expected next year, so we don't multiply the dividend by 1 plus g. Okay. This is a simple example of Gordon's growth model. Computing growth formula. Okay, before we do that, here's you and I will walk together. Let's draw a timeline. Time 0, time 1, 2, 3, 4, and 5. Okay, dividends, DPS. Year 1, DPS is 4. DPS is 4. Year 2, 6% higher than that. What is the dividend per share? I want you to bring your calculator out and help me. What's the dividend per share at time 2? Come on. You don't need a calculator. 4.24. Okay. And what's D3? 4.24 times 1.06. 4.4. For 9, okay. And D4. That times 4.7. Round it. Round up. 77 or 76? 6. Okay, times 1.06. 5.05. Okay? Is it okay? Okay? It doesn't involve any formula. It is simple growth. Applying the growth rate and see what it looks like. Now, as Sujin did, P0 is equal to expected dividends 4 divided by what was it? 16? 16 minus 0.06. So it was 40, right? Now, suppose you are right here, immediately after you receive $4 dividend, and you look at the future, and you see that the stock is going to pay $4.24 in 1 year, and $4.49 in 2 years, and $4.76 in 3 years, and so on. Okay? So P1 is equal to, what is P1? What should I divide? Which number? Hwang Hee, what number should I divide? 4 or 4.24? Okay, 4.24. And down here, what do I have? Right? And the number is 4240, right? And you can do a calculation of P2. It's 4.49, 0.16 minus 0.06, and that's 44.90, right? You can do that. Let's go to P4. 5.50 divided by 0.16 minus 0.06, and it's 55.50, right? There may be some rounding errors, but forget that. But important point that I would like you to find is the following. Price times 0 becomes price times 1, okay? As dividends are growing at 6% per year, how about the growth rate of price? What's the growth rate of price? P1 divided by P0 minus 1. That's the growth rate of price. So P1 is 4240 divided by 40 minus 1. And that's what? %. And the 6% is same as the growth rate of dividends. So price change in this model, price change is the same as dividend growth. Price is growing at the same rate as dividend grows. So let's answer the question. What is the price expected to be in year 5? And we did it. Year 5 price or year 4? Year 4 is 50-50, right? What is the implied return given the change in price during 4-year period? Price rises from 40 to 50-50 for 4-year time, and implied growth rate is 6%. And you saw this using just one example. Okay? Growth rate of price is 6%. The price grows at the same rate as the dividend. Right? The bottom line is the conclusion of this model. I want you to understand the workings of this model. This model will serve as the foundation for many other topics. That's why I'm asking you to painfully understand how the numbers or variables work out. The same can be proven or illustrated by using mathematical formula. Price T is the following, T plus 1 is following. Again, the price grows at the same rate as the dividends. Okay, any questions? Any questions? Let me go back a couple of pages. Coming back to this problem, one final remark. Back to this problem, one final remark. Price change, annual price change is 6%. So growth rate in price is the same as growth rate in dividend. Okay? How about dividend yield? This is a new concept, dividend yield. Dividend yield is dividend at time 1 divided by today's price. That's called dividend yield. Like coupon yield. Coupon yield is coupon payment divided by the price of a bond. Same thing. Dividend per share divided by the price per share. And D1 is $4 per share and price is 40. So dividend yield is 10%. Okay, now here is the real important detail. R, required rate of return. I want you to pay attention. Okay, this is a very important part. Required rate of return has two components. The first component is dividend yield of 10%. Dividend yield of 10%. Plus capital gains yield. Price changes by 6%. So required rate of return has two components. One is dividend yield component and capital gains component. So when you invest in stocks, you receive your income in two different ways. One is through dividends, the other one through capital gains. It's same with bond investment. You remember the bond investment case? Dividend yield, coupon yield plus capital gains yield. Same thing here. In bond stock investment, there is dividend yield component and capital gains component. And this capital gains component comes from where? Where does it come from? Growth of a company. Growth of a company. Questions? Okay. The third example. This is the toughest part. Once you know it, it's not that tough, but at times it's a bit confusing. Suppose a firm is expected to increase dividends by 20% for 1 year and then by 15% in the year following. After that, dividends will increase at a rate of 5% per year indefinitely. And the dividend at the time zero, dividend was 1, and the required return is 20%. What is the price of the stock? Remember that we have to find the present value of all expected future dividends. Okay, so the next page has how to solve this, but for your benefit, I'm going to draw this timeline with you and see if we can find some insights of this particular model. Here's the timeline. 0, 1, 2, 3, and 4, and so on. D0 at today's was 1. It's $1. And for the first period, dividend increase, growth in dividend for year 1 is 20%. So year 1 dividend, what is year 1 dividend? Okay, $1.20. That's dividend per share at year 1. I want you to pay attention, okay? And from year 1 to year 2, the following year, the growth rate will be 15%. The company is at a growth mode. It is growing very, very aggressively, and it grows at 15%. So 1.20 times 1.15, what is it? Huh? 1.38. Okay. From that point on, the dividends are expected to grow at 5% per year. G is 5%. From that point on, it's for good, forever. It grows at 5%. It's like a normal company. During this period, it's a supernormal company, supernormal growth company. But from year 3, it's growing at a normal rate of return of 5%. So what's D3? 1.4449, so 1.45, right? And D4? Actually, you don't need to compute D4, but 1.52. Okay, that's enough for dividends. Okay? How do we solve this problem? How do we solve problem? Remember, it says, remember that we have to find present value of all expected future dividends. D3, D4, D5, D6, and so on, until D goes to infinity, okay? That's impossible to compute. But we know that at time 2, right here, after the second period dividend is paid, you look to the future, and you see that this company is a normal growth company. So price at time 2 is, using the golden growth company growth formula, D3 divided by R minus G. And D3 is here, $1.45, and R is 15%, and growth rate is 5%. So P3 is $14.50. Are you with me? You follow me? Okay? Is it okay? If you don't understand, raise your hand and stop me. I'll explain it to you again. price as of time 2, from time 2, after this period dividend is paid, this company is like a normal company. There's nothing abnormal about this company. This company is growing at 5% per year, right? And you use this Gordon's growth model in a straightforward fashion to compute the price at that time. Okay? Price is $14.50 in year 2. Year 2, you receive dividends of $1.38, and year 1, you receive $1.20 dividends. So discount it back 1 period, discount this number back 2 periods, and discount this number back to 2 periods, and you have the price at time 0. P0 is equal to 120, 1.15 plus 138 plus 1450 discounted by 1.15 squared. That gives you the value. Yes? What? What? I'm sorry. That's why you were so puzzled. Well, I intentionally did it, so as to check whether or not you are sleeping. What's this number? Please? Huh? 9.67. Okay? $9.67. So $9.67, 1.20, and 1.20. So this is 1, and this is, I don't know. What's this number? What's this number? This is 7.67 plus 1. Okay, let's see whether our computation is right. If it is not right, then yeah, here. Compute the dividends until growth levels off. D1 is $1.20. D2 is $1.38. D3 is 1.449. Find the expected future price. P2 is D3 divided by R minus G, and 9.66 or 9.67. It's because of the rounding. Find the present value of the expected future cash flow. This is exactly what we did, and $8.67. Ah, we got it right. Right? Are you with me?
Yes.
Okay. Okay. That's all for today. And here's your project description. By today, you are going to do the first part, and by I take that back. By Wednesday, you do the first part, and by Monday, a week from today, assuming the cost of capital of 8, 10, 15%. Now, notice that I'm using the term the cost of capital, which is the same as required rate of return. Okay? Required rate of return of 8, 10, 15%. Compute PVGO, that's present value of growth opportunities. Present value of growth opportunities. PVGO of the company you are analyzing, and compare your answer with those of your colleagues in your group. Submit your report by Monday, April 27th. This is the homework that you will have to do by Monday. And on Wednesday, I'll talk about how to compute PVGO for general company, and you will apply that method to compute PVGO of the company that you are analyzing. Okay, that's all for today, and I take that back. That's not all, but that's all for